Hello and welcome to Altitude. I'm Russell Porter. I head up stakeholder engagement for new airspace users here at NATS, and I'm pleased to host this month's show. Today we're talking all things drones or uncrewed aviation, and specifically how we work towards beyond visual line of flight site operations and why that's so important. A huge amount of progress has been made in recent years, but what are the challenges that still exist, and what are the opportunities for new services and solutions? No one is better placed to discuss this than our panel this month. We're delighted to have Louisa Smith with us, Head of Aviation at Apian, a startup focused on drone delivery of healthcare. Hello, Louisa.
Hi, good afternoon.
And Charles Taverner, CEO of Flylogics, a pioneering company focused on environmental monitoring with big name clients in the energy sector. Hello, Charles.
Hi, Russell. Great to be here.
Thank you. Before we get started, it's just a quick reminder that we are live, so please do pose any questions that you might have for us in the chat, and we'll do our best to get them to the panel. Charles, I'd like to get started with you. Could you give us a flavour of the work of Flylogics and how that's developed over recent years?
Yeah, thanks, Russell. So what we do at Flylogics is we use long-range uncrewed aircraft to reduce the cost, the risk, and the environmental impact of delivering aviation services. But as you said earlier, we focus almost exclusively on methane emission measurement of offshore energy facilities. So our customers include companies like BP, Shell, Total Energies, Equinor. And what we actually do is one of our uncrewed aircraft will take off from an airfield somewhere in Aberdeen, Shetland, Norfolk, or Blackpool. It'll fly several hundred kilometres out to one of those facilities, and then it'll spend about 30 minutes around that facility gathering methane emission data. And the beauty of that is that gives our customers a very accurate picture of their emissions, and we do so in a very low impact way. As you can imagine, that's a pretty complex BVLOS flight. You know, it's over 500 kilometers covered over that. We will be interacting during that flight with helicopters, other air users, air traffic control, as well as the asset themselves and ships and things operating in the area. And we think that that's a fantastic blueprint to some of the broader applications, and I guess some of the stuff that Louise is going to talk about in a minute. It's a great example of where BVLOS is being used today for real commercial activity.
Thank you, Charles. That's a really interesting use case. How did you identify it?
To an extent, it's like all these things, it's slightly iterative. We were certainly guided by the regulator in the early years, where they said, you know, the place to go looking is somewhere that is remote, something that is commercial, and something where we can offset other aviation risk. And so those were sort of guiding stars. And as we got into it, obviously there are a number of applications offshore, but that methane emission is something that an unmanned system genuinely does a better job of than any other way of getting that measurement.
Thanks, Charles. You also mentioned the distance there, and it's quite significant. Is there anything special about your aircraft, the drone, that allows it to fly so far?
Yeah, I mean, the nature of that operation is, as you say, it's a fairly long one. So it is an internal combustion engine, so we can get that sort of range. And of course, the communication systems that we need are well beyond line of sight. So it's satellite communication. There's obviously a lot of complexity in working with the other aircraft, with air traffic control and the asset. So I guess the two things that technically demanding about that are the sort of communications and just simply the range in the likely conditions you see west of Shetland. It's certainly an entertaining place to operate.
Variable weather conditions.
Yeah.
Louisa, over to you now. Could you tell us a little bit about the work of Apian and your operations?
Yeah, sure. So Apian is a medical drone logistics company that's been founded by NHS doctors and some ex-Googlers. And we're looking at integrating drones into the NHS and healthcare industry. So we're drone agnostic, so we work with a variety of drone operators. And we also work with lots of different NHS trusts across the UK. And our kind of aim and goal is to essentially create a smarter, faster, greener healthcare industry. When we talk about use cases, we are really focused on the use case of, the need for the NHS and for the clinicians and patients. So at the moment, there's so many different use cases, but for the moment, we're kind of focusing on chemotherapy, where we've conducted some trials on the south coast between the Isle of Wight and Portsmouth, where chemotherapy is transported from Portsmouth to the Isle of Wight for patients. We did that work with Skylift, who were the drone operators for that project. And we're also looking at doing some chemotherapy tests in Northumbria with the Northumbria NHS Trust up there, as well as looking at moving pathology samples. There's some really good use cases for pathology samples across London, which obviously is a huge challenge on the aviation side, and given that it's would be flying over urban environments. So we're really focused on the use case, where the hospitals need it, what's needed for the patients and the clinicians, and kind of work back from there around how we would integrate drone operations with that.
Thank you very much. You mentioned that as an organisation, you're drone agnostic. When you are selecting a supplier or an operator, what do you look for?
So we have a tender process, and it's normally around, depending on what the NHS requirements are. So obviously some aspects might be lightweight, some might need a longer range, some might be quite small distances, like 2 or 3 kilometres. So it's all around what the drone ability is and the payload and the capability. We're also looking obviously at, as kind of the industry is looking at a sustainable future, so predominantly looking at electric sustainable aircraft as well.
Fantastic. You mentioned their capability of the drone. So what kind of technologies typically would a drone have on board in order to fly in? You mentioned London, so over the kind of London airspace, what would we be looking at?
Well, so it's interesting really. So the drone technologies is not necessarily obviously the different aircraft have different type of equipment on them. Some might have ADS-B in and out so that they have electric conspicuity. Some may not, depending on what the drone operators are operating with. Predominantly at the moment, obviously the London TMA is a requirement for aircraft, for manned crewed aircraft to have electric conspicuity on them, and it's in a controlled environment. But actually some of the stuff that we're looking at is really around the procedures and how we would integrate with crewed aircraft and aviation. So some of the challenges around some of those complex airspace is actually around how we would integrate seamlessly kind of drone technology alongside the more traditional aviation systems.
Thanks, Louisa. I'm going to think a little bit more broadly now, talk about the industry and some of the predictions for the industry. So the PricewaterhouseCoopers report, The Skies Without Limits, makes some really significant claims about the drone industry in 2030. Some of the stats include 45 billion pounds contributed to the economy, 900,000 drones in the UK's skies, and 650,000 jobs created. So huge numbers. Charles, what do you think are the main challenges in achieving that level of growth?
Yeah, I think there are, so as that is alluding to, and certainly as we see, there is demand for these types of service in the particular cases that Louisa and I are talking about. The first place everyone goes is regulation in this type of conversation. I think what I would caution slightly is the regulation allows us to do that today. What we find is the regulation is not very elegant. It's not very efficient at the moment. And you have the community and CAA and NATS working to make that a more streamlined way of doing it. But you can operate today, and there are a number of cases of people doing that. Louisa, I think you sort of almost touched on this. There was a sort of comment about technology, which is the next place people go. Again, actually, there's quite a lot there from a technology perspective. Certainly, it's a big part of our work, refining the satellite technologies, refining the aircraft. But as you allude to, it's operations actually where there's a lot of work, and I think is probably a little bit unloved. What we find from doing real operations day in, day out is that it's how you interact with the helicopter pilots, how you interact with NATS, how your procedures capture that thing, what happens when fog rolls in. There are a huge raft of much more operational things that it's typically neglected in these conversations, and probably is where most of the work lies over the next few years.
Thank you. One of the words that comes up a lot when we talk about the drones and their eventual integration is the fact that today requires segregation. When you are delivering your services day in, day out, Charles, what's the method of segregation that's currently used? Can you describe that to us?
Yeah, so the way, those of you that look on the portals will see, the way we deliver work in the North Sea is we put in place temporary danger areas, and you will see long, thin fingers of segregated airspace that, up to 1,000 feet that come out from the coastline out to a particular asset. So the way we're achieving that at the moment within current regulation is segregation. We work very, very hard to make that segregation such that it really has very little impact on anyone else's operation, but undoubtedly it's segregation, and that's not good for us, that's not good for other air users. And so CAA, yourselves at NATS, all of the other drone providers have a vision of where we're going towards structures more like transponder mandatory zones, where we move away from segregation and we allow more freedom for everyone. I mean, that's in our interest, and that's in every other air user's interest.
Thanks, Charles. The drone industry is certainly really fast-paced, and yet traditional aviation really has to be conservative in its approach to change. Louisa, how do you think the two can be reconciled such that the drone industry can respond in that pace that it needs?
Well, it's kind of interesting, isn't it? Because some of the I was looking yesterday actually around some of the first use cases of drones, and actually it goes back to World War I. So I'm not actually, the concept of uncrewed aircraft isn't actually that new at all, and so I might challenge you a little bit on how quickly it can be and fast paced, if I'm honest. But having said that, there's definitely a need to look, I believe, in other industries, and especially where we can learn from other sectors that have had to use regulations and to do something quickly. And I think a really good example, which is obviously kind of relevant for us, sorry, at Apian, is the recent COVID vaccine, where the structure to get that approval is normally quite significant, and obviously it was compressed. And realistically, when you look at that why that was the case is because the use case was there, and the use case and the need for us to have that and the regulation to be looked at and more kind of compressed was needed, for obvious reasons. And I think that's the case with us in the drone industry, where we do need people to really understand that these use cases can significantly benefit the safety, and for our use cases can benefit people having their kind of healthcare provided by the NHS. So for me, it's around ensuring that we learn from other areas, but that the main sense of that is we need to really understand what the use case is and why we need to do this. And it's not around just flying drones for drones' sake. This is around essentially making better healthcare, higher safety standards, ensuring that people can benefit from the use of drones. So, yeah, I think that's probably why I stopped talking then.
Thanks. You talk about the use case there, the one of medical delivery. It's certainly one that has caught the attention of society, I think, really generally, broadly, and indeed globally. There's companies like Zipline operating in Rwanda. They claim to have saved over 1,000 lives already with blood deliveries. Skyports working in Scotland, providing test samples between remote hospital locations. What was it that led to Apian focusing in on chemotherapy drug delivery?
So I guess there's quite a few different use cases, but chemotherapy is one which is the shelf life of it is quite short, so it's 24 hours before it needs to be before it ends up being redundant. The example on the Solent, which I mentioned earlier, the chemotherapy is manufactured in Portsmouth and transported to the Isle of Wight St Mary's Hospital, where it's provided to the patients. That can take up to 4 hours for transit, so it has to go, be made in Portsmouth, taxi, hovercraft, taxi to the hospital. A drone would be able to do that in about 32 minutes. I think this average was. So you can see already that doesn't really need that much explanation, but it also means that people might have the kind of catchment of area of people being able to receive that treatment might be able to be expanded. It means patients can have more chemotherapy that's made specifically for them, and things like that. Obviously, people have tests before they're allowed to have their chemotherapy as well, so potentially there's a wastage as well. So there's a huge use case on around the chemotherapy. There's also other examples where, in London, for example, one of the use cases we're kind of focused on at the moment, the pathology being sent can take between 90 and 100 minutes, and that's a 3-kilometre distance in the central London. Actually, that can really impact the results and treatment that people are receiving. So if we can shorten that down, and again, a drone would be able to do that in about 4 minutes. So it's around ensuring that there's that sustainable, consistent delivery of services that can actually fundamentally change how healthcare is delivered.
Thanks, Louisa. It's an amazing use case. I also understand there's a really nice story behind the naming of the drones. Would you like to share?
Yeah, so we asked some of the children's patients at the Isle of Wight on the chemotherapy ward on the cancer wards to provide some ideas around what the drone should be called. We had quite a few applicants, and it was quite like a heart-wrenching, like quite emotional process to go through. It was called Buzz Rainbow in the end.
Fantastic. In your description there about learning from other industries, Charles, I know that you look at F1. What have you learned from the kind of Formula One side of life in terms of drone operations?
Yeah, so you're absolutely right. We have several of my colleagues come from that background, and to some of the points that are being made earlier, we are trying to go up a very steep learning curve very quickly. So we want to set the highest possible standards of safety and performance, and we're coming from much further behind than, say, commercial airlines on that. So that requires us to go up that curve steeply. Formula One's an interesting parallel because you've got that same thing. You've got a very tight feedback loop. So, in their world, in many ways, it's simpler because you've got that sort of 2-week cycle with a feedback loop. But there are some pretty helpful analogies around. It's a sophisticated system. You are getting an enormous amount of feedback from the aircraft. In our case, we in fact use one of McLaren's bits of software called Atlas. That's what they use plugged into the F1 car to analyze it. We use that to analyze the aircraft. Every time an aircraft lands, we download all that data, our engineers pore over that, and then we feed that back into the next flight. And that's not out of some strange masochism. That's because what we're trying to do is we're trying to get all that information, feed it back in the aircraft and make it better on the next one. And that's because of a fundamental belief that we're trying to compress 100 years of aviation expertise, sort of experience and knowledge into what's probably only a 10-year period. So we've got to do something quite different.
Nice, very nice. So talking about aviation experience, on your founders video on the FlyLogix website, you talk about the aspiration for FlyLogix to become either the Boeing or the Airbus of the drone industry. What will it take for a drone company to do that?
Well, I think there's a natural process, isn't there, where as an industry matures, you start to see regulation mature. You start to see stratification. So you start to see operators, builders of aircraft. And actually, that's quite difficult for us to do at the moment because you don't have those neat breaks around pilot qualification, aircraft certification. And so what we expect to do is we expect to see that maturing of that stratification. And then we expect to see consolidation. So and ultimately in commercial aviation, you see it consolidate into a much smaller number of operators, a much smaller number of suppliers. And yeah, that is a process that is clearly going on already. You've got thousands of fantastic, innovative companies, and they're starting to come together. We partner with another business in order to deliver the service we deliver. You're just going to see that consolidation into something that I have no doubt in 30, 40 years will be matured out into a small handful of very, very experienced, very well recognized names.
Thanks. In that same video, you mentioned that your very first BVLOS flight was the result of a bet, a bet that you couldn't achieve it. I was just wondering what FlyLogix have done over the years that have followed to take chance out of the equation to result in the sophisticated service that you offer your clients today.
That's a great question. I mean, it is that combination of, you've got three pillars. You've got technology, you've got the regulation, and you've got the operations. And to your question about chance, the place where most of that is taken out is actually around operations. So that is about, redundancy in crews. It's about spares. It's about duplicate aircraft in locations. There's some stuff about, managing the regulatory process. And it's a journey, Russell. It is definitely a difficult thing to do at the moment in such a steeply growing sector. But all the time we're getting, more clarity from the regulator about timing, the way they do things, the way they want it structured. We're getting better at, having the right spare parts in the right place to run an operation. We're getting better at weather prediction. It's just a constant iteration, which comes back to the thing we were talking about before, which a lot of it is about do it, learn, feed it back in quickly. And that's why we've gone up that curve quicker than many others.
Fantastic. And yeah, the conversation we were having before was on my mind, and learning is obviously a key tenet of any safety culture, and it's obviously core within aviation. How do you, as drone operators, as drone companies, ensure that you're able to learn continuously?
Well, so there are a set of established tools within the aviation industry, things like AirProcs, MORs, AAIB reports. We enthusiastically embrace those because it's that type of leading indicator that allows us and colleagues or other groups like Louisa's group and the regulator and NATS to learn from it and start to spot trends. If we don't feed anything in at the bottom, it's difficult to see those trends, and then it's difficult to work on. So certainly in that area, we're trying not to reinvent the wheel. We're trying to sort of embrace the things that aviation has spent 100 years learning the hard way, and use those tools to get up the curve quicker.
Thank you.
I think on that point, sorry, Russell, is also stuff like the BVLOS forum, which we're obviously all members of, as with others as well, where and obviously NATS have kind of set that up, where we actually exchange kind of safety reports and stuff like that as well. So there's kind of a forum where actually the industry is moving together as well, and acknowledges that we need to work together and collaborate to allow and enable this vision of ours in the future. So there is this real acknowledgement about that.
Yeah, no, it's amazing when you sit in that forum. We battle problems where we think, oh, we must be the only people that have ever come across this, and you brace yourself to mention it in the forum, and then immediately three other people go, oh yes, we've seen that as well. And that's part of the learning culture.
I've done well not to mention the forum, so thank you both for doing so. In terms of that forum, how can we get the message out for those things that we are learning as the kind of member organisations? What's going to be the best way that we can do that?
I think we have to get like a collective voice and kind of ensure that we, share our learnings externally, share it with other partners, with other people who aren't on the BVLOS forum. It's making sure that group has visibility externally without needing for people to be kind of in that group all the time. So I think it's really about open, honest sharing of what we're doing, and how we get that kind of community voice to be able to push that some points forward as well.
Thanks. A change of tack, and an equally important topic, and I'd like to pose the question to both of you, because I think you hopefully have different aspects on both of it. So David Attenborough tells us that the world is in trouble, and aviation is working really hard to decarbonise. How can the adoption of drones help?
Do you want me?
Charles, go ahead.
Let me have a start. So look, I think it is simple physics. You know, it's a fundamentally energy intensive activity, putting a large object into the air. And as we started to get into this 7 or 8 years ago, we started to see that there are lots of aviation services that are provided by crewed aircraft that would be far, far better done by a smaller, uncrewed device. So the example I always give, police helicopter, 2,500 horsepower aircraft, is largely, in most of its use cases, flying a GoPro. And so, you know, that is just not an efficient way of gathering that data. And I think the surprise to me as we started the business was actually there's quite a few of these pockets. I had been a bit myopic and just been thinking about commercial airliners, and I will not get on a commercial airliner for many years with a computer only flying it and no one up the front. But there are all these other applications where actually an uncrewed system would just do a much, much better job. And that system is smaller, lighter, and it's just fundamentally less energy intensive way of doing it. We've tried to sort of pull that full circle and focus the activities we do on energy reduction activities, which is why we do the work around methane. But it's that belief that we can provide aviation services with a much lower environmental impact.
Fantastic. Is there something in there then about the overall displacement of other vehicles as well, both perhaps land-based and other forms of aviation?
Yeah, I think I mean, the energy industry, for example, is very public about its intention to reduce the number of people offshore, and this is just aiding that. You're providing more services to do that. You mentioned earlier, Louisa, about electrification. We would love that. That's obviously something else we'd love to do. Just the 500 kilometers makes that rather challenging at this stage.
Yeah, definitely. I was going to say that the NHS accounts for between just under 5% of all road traffic usage on the UK roads. So actually, there's a huge amount of benefit that can be taken if it's going to be moved to a more kind of sustainable. And yes, there are ways of doing that with electric vehicles as well on road vehicles. But actually, wouldn't it be great if we could fundamentally change how the logistics works and provide better healthcare as a result of that as well?
Thanks, Louisa. Changing tack ever so slightly. Charles mentioned autonomy there briefly about the flight deck and not wanting to get on board an aircraft anytime soon that doesn't have a pilot on board. Louisa, what level of autonomy do you currently use in your operations when it comes to drone flight?
So mostly things are at the moment quite manual in a sense of who's going to collect the package, who's going to deliver it, how's it going to integrate into the NHS. But there are lots of automations that are being looked at, and robotics, factory robotics and things like that isn't new for lots of other industries. So looking at that type of stuff is also important. And then also looking at multimodal. So, maybe a drone can't deliver everything that we're looking for, and maybe it needs to interact with other forms of transport, and also some of those kind of robotic sides of it are being looked at as well.
Can you hand fly a drone? So could somebody sit in an office and manually fly the drone?
Yeah, so some of the BVLOS operations are beyond visual line of sight can be done basically remotely. That's the whole point of it. Mostly they're done on the site of the kind of like either one of the landing sites at the moment, but that changes, and different drone operators have different kind of models on that one as well.
Thanks very much. So we've talked quite technical there. We've talked on a lot of technical topics. I'd like to change tack again and talk about what it's like to work in the industry. What does a day in the life of a drone company look like? Perhaps Louise, you'd like to answer that one.
Yes, so I mean, I work with doctors and ex-Googlers, so all of our roles are very different, but mostly we're doing quite a lot of stakeholder engagement with the NHS Trust, working with different, so for my role specifically, looking at working with different aviation community members, looking at how we can design and look at moving towards permanent operations and how the impact of that would be on the aviation community. So a lot of it is around exploring the use cases, how that would work, looking at how the drugs are going to be actually moved, what requirements they have for the moving. Sometimes they need to be kept at a certain temperature and things like that, and working with the NHS Trust to work out what their use cases are, and then trying to embrace or kind of speak to the aviation community to ensure that they understand the reasons behind what we're doing.
Thank you. And Charles, maybe there's a similar one from the energy industry perspective.
Yeah, so I mean, it does break, our day job breaks down into those three areas of operations, regulation and technology. So if we start with operations, there's an enormous amount which is about getting the right people into the right place with the right training. And in our world, there is a piece as big as the aviation piece, which is about how we interface with an offshore facility. These facilities we're going around are incredibly complex. They will have ships alongside, unloading, helicopters coming in and out. There's a whole HSE management piece, safety management piece that is completely separate from the aviation one. So there's a big part of my day and my team's day that is around that management of that operations. Undoubtedly, that piece about regulation is a big thing. So there is how we do it today, which is, as we've sort of alluded to, a little bit quite cumbersome, but functional. And then also how we think and work with the rest of the community to get to something that is more elegant and works for everyone. So not just drone operators, but for GA, for helicopters, for everyone else that uses the airspace. And then, of course, there is a technology piece. So the whole point about going out and doing it is we learn all the time, and we learn what matters, what bit of the communication system needs to be improved so that you've got the sort of latency that allows you to do what you want to do. So there is that just constant iteration between those three beyond any kind of commercial, simply selling business or the sort of managing that part of the business. But it's fascinating. I mean, I genuinely love it. I'm proud of it. My daughter's proud of it. It's a good thing and a fun thing to be doing.
It's like it was almost scripted there. I'm glad that you mentioned your daughter, because in the aforementioned video that we spoke about, you state that you're brainwashing your daughter to become an engineer in the aviation industry. It's clearly an exciting time for the industry. So how can those in education and the early stages of their career, how can they get involved?
Well, yeah, so I'm very proud. My daughter got 94% in her physics test the other day. It's a big moment for me on that brainwashing. A lot of our team, certainly a lot of our team, have an interest outside work on what we do. So they model fly, they fly crewed aircraft, they are, into technology. So there is undoubtedly a piece that makes people, particularly in a fast-moving place like this, if they're doing stuff outside their work that is relevant, it is enormously powerful. We try and do stuff that's more structured. So one of our engineers is halfway through her engineering degree and is on a sort of 1-year sandwich with us. So we try and do more structured stuff. We've sponsored students in the past that have joined us from various universities. So yeah, it's a sort of combination of those things. But there's just so many opportunities at the moment to get into it and engage in it in people's private time, and it really pays. The employees we have that understand that world are so much more productive in the workplace because of it.
I'm always really struck by the level of enthusiasm and passion that we see in the BVLOS operations forum. It's really incredible. On a similar related theme, Louisa, we were ex-colleagues in a previous role of yours, and you were a huge advocate for diversity and inclusion. I was just keen to know, how do Apian create and maintain diversity and inclusion in the workplace?
Yeah, so I've been quite vocal about this before in the past. Like with research, development, or innovation, you need diverse thinking. You want different people to think differently, to come up with different ideas. But equally, you need to be able to challenge different people on ideas. So you need that inclusivity to allow people to feel like they're safe in a safe place to be able to challenge. So with Apian, we're actually a relatively diverse team anyway, which I also think is quite helpful. But we really embrace our differences and see it as a real positive. And equally, we have kind of diversity events that we kind of do as a team to make sure that we keep kind of making sure that we're open to the conversation and bringing back learnings. But the inclusivity bit is really important, and we don't operate a hierarchical structure at all. So everyone is able to question and challenge each other. And we're really all kind of working towards the purpose of the company. So it's all what's the best interest of the company and how do we move it forward, and we can all build on each other's ideas. So for me, it's really important. The diversity and inclusion is a little bit of a buzzword to some people at the moment, but actually for research and innovation and for development of these types of things, we really need it.
Thank you, Louisa. Charles, you mentioned training in your response to the previous question, and we've had a really good question in from the audience. So thank you, Alan. Alan states that pilots of manned aircraft have to undergo training not only for flying the aircraft, but also understanding of the airspace they intend to fly in. How is this achieved for a drone pilot of a BVLOS operation?
Yeah, that's a great question. So there absolutely isn't a script today. There isn't a clear certification. What we have is a hybrid. So exactly as Alan points out, the way we tackle that today is predominantly expecting our pilots to have crewed pilot qualifications. That's a very it's a slightly crude way of achieving understanding of airspace, air law, meteorology, that type of thing. And what we're doing with time is we're starting to understand which parts of those are more relevant to the BVLOS activity. So we're sort of slightly over deploying on that. And then what we're starting to do is understand what particular pieces we need for a BVLOS operation. And frankly, the regulator is starting to get a clearer view of what they expect. So there are certain things the regulator has introduced recently about sort of basic levels of expectation. So you're coming at that from lots of different areas, and there are things that are different in a BVLOS thing. So it isn't even as simple as if I have someone with a certain crewed qualification that's good. That certainly covers off some of the things that Alan's talking about, but there's more.
Thank you very much. You made reference there to the work of the regulator, and alongside that piece about competency and training that they're doing, there's also a section on flight worthiness. And one of the questions that's come in from Paul is, what are the airworthiness requirements and how are these monitored? Louisa, would you like to tackle that one?
It might be best if Charles does, if I'm honest. Essentially, the kind of everything is managed by the CAA and reviewed on a case by case. So approval to fly from the drone operator is kind of done on a case by case review. And there's different sections. It's the operational safety case, and that will be examined by an appropriate member of the CAA. And that's also linked in with the airspace requirements. So when Charles talked earlier on about requesting a temporary danger area, there's a set of requirements around the airspace part of the CAA where they're also reviewing regulations on that side. I don't know if Charles has got anything else to add on that one.
Yeah, there's more. You're absolutely right, Louisa. There's this sort of fundamental thing that at the moment we put a safety case in for the whole thing wrapped together. We don't have it segmented into separate airworthiness, pilot competency. That's all together, and you're looking at the whole piece in a whole to make a risk-based argument. But what we are seeing is that maturing. And so airworthiness is a fantastic example of it. What we are starting to adopt, and this is an example of an area we are on a very steep curve on, is we're starting to adopt approaches that are very, very similar to crewed aircraft. Engineering management systems that you would expect to see, job cards, all the types of things that would be very familiar to any other walk of aviation. Because essentially it's critical that a pilot flying a helicopter out in the North Sea can look across as our aircraft goes by and know there is a degree of equivalence. They understand in all the different areas, pilot competence, airworthiness. It might not be exactly the same, but there's equivalence at some level, and that is a critical part of the safety case.
Fantastic. So on the topic of regulations, John has asked, what one realistic quick change in regulations could make a difference to your operations? So I'll put it to you both, maybe Charles, as you are on the mic there. Would you like to go first? No pressure.
To be very frank, a timetable. So given what I've described earlier, that all things are possible today because you put a safety case in, it's a fantastic system at the moment. You're able to do really interesting and challenging things, but you have to put a complete bespoke safety case in. That's no problem, but what we need is a timetable of when we get to the various other stages. And that can be as tactical as, how long does it take to get a TDA through? So timetable around that, through to what's the timetable over 4 years to get to different airspace structures or something like that. Timetable is key because you can plan against it.
Thank you. Louisa?
I think of something very similar. I think that's obviously quite one that's relevant for us as well, with around the timetable. I think for me, going back to kind of the use case, there's definitely examples where the regulation doesn't necessarily make sense. And then what I mean, definitely need to explain this. And what I mean is that a doctor would not be able to take out a pathology sample from a drone because they haven't got the right aviation requirements to be able to do that. So there's definitely some mismatches in those things, which actually, if we could resolve those, which are, we are working closely with the Civil Aviation Authority to look at some of these examples where actually, a medical doctor who's allowed to input all these medicines and stuff like that should be able to pick it up out of a drone. So some of those kind of nuances would be useful to kind of remove.
Yeah, so to get that kind of cross-industry regulatory understanding.
Yeah.
Perfect. We've got a question that actually sounds a little bit like the statement that you made earlier, Louisa, so I'm going to ask you it. So this is from Miranda. According to Google, the first radio-controlled aircraft was built in 1938. Why has it taken 80 years for commercial uncrewed aircraft to become a concept? Great question.
Yeah, well, that's interesting because I had a different date in my head, so maybe I got that wrong. So I think there's been a lot when some of the research that was done in early days is predominantly in the military domain for obvious reasons, and so there was a lot of work done in that area. And I really think that for me, especially because I've moved from an aviation kind of company to working for to a healthcare company working for, it's quite obvious to me now, maybe not a year or 2 years ago, that the aviation industry is developed and concerned around ensuring that the drones can fly in the aviation, in the airspace. Again, it's around that use case and how do we develop this whole industry that needs to be able to adapt and develop its systems to be able to utilize the drone. So I think realistically, some things have taken a long time because the use case has not necessarily been completely understood. Whereas now I think we're in a position where, ours and Charles's example earlier on, and there are lots of others, the use case is really there now and it's needed. And the examples that I've mentioned earlier on around the chemotherapy, that's not talking about how we could impact the industry in 5 years or 10 years. That's talking about how we could impact healthcare delivered today, if we could get that moving today. So it's really around, for me, making clear about why we're doing this. Why do we want drones flying?
I think there is a massive technology enabler in there as well, which is that, we have been flying uncrewed aircraft for many, many years, things like military targets. But some of those have been operating BVLOS. But what we're now asking them to do is interact with lots of other aviation. If you fly a target, you're not asking it to interact with very much else. You're not even asking for it to come back in most cases. What we're asking these things to do is interact with other aviation, and lots of it, and interact with people. And what that requires is a lot of processing power. It requires cost-effective microprocessors. It requires comms networks that, frankly, low-cost SATCOMs, low-latency SATCOMs has not existed until the last 20 years. So there's quite a lot of technology stuff that has fallen into place at the same time as the requirement for, the demand started to fall into place. So it's just that, I think it's that classic thing that you can see a technology revolution a long, long way before enough stuff has fallen into place to actually enable it to happen.
Thank you, Charles. Thank you, Louisa. And thank you in total as well, because unfortunately that's all we have time for today. So I hope you've enjoyed watching the show. A big thank you to Louisa and Charles, and also for all of you who watched, and for putting forward some really interesting questions. The show will be available afterwards on the NATS YouTube channel, and as well as an audio podcast. Please keep your eye out for our social channels for details of the next show. And also, if you could please keep your eye out on nats.aero for the publication of a white paper that we'll be putting out there soon for BVLOS operations. Thank you very much, and goodbye.